Alright, so yesterday made a video regarding 56 equals 7 times 8. 5, 6, 7, 8. And similarly, 12 equals 3 times 4. 1, 2, 3, 4, 5, 6, 7, 8. Really easy to learn. There's no excuse for people to not be familiar with this. This should probably be taught right after kids are able to count. Because you don't even have to be able to count all the way to 10. Remember this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2 equals 3 times 4. 5, 6 equals 7 times 8. Very easy. Okay. And then I walked through the prime numbers whose ones digit was a 1 between 2 and 100. Okay? And if you notice in the video, I did a misdirect with 81, right? Because 21 and 51, there's a 7 times 3 that's really obvious, but 81, we learned it as 9 times 9, so I did a little misdirect there. I also counted 91 as a prime number in here. That was also a misdirect because it is not a prime number. But it is actually doing something very similar. You do get a 7 times 3 in there in terms of base 10, right? Because we use a base 10 system. So the other ones, what's happening is you're adding 10s to the 7 that you're multiplying. With 91, you're adding a 10 to the 3, right? So 21 is 7 times 3, 51 is 17 times 3, 81 is 27 times 3, 91 is 7 times 13. Okay? So there's some patterns that are occurring in this that are actually really nice and kind of show us what's going on a little bit more in depth. And if you had a proper intuition about 7 times 3 being 21, these things would make more sense. And the fact that they don't is my prime evidence that this claim that 3 times 7 is 21, this is bullshit. This claim that's intuitive. It's not intuitive. That 3 times 7 is 21, that is intuitive to people, that it feels good. I don't believe you. Okay. For one thing, what we can do is we can kind of break down, say 56. So let's look at the 56 as 7 times 8. Well, the 7. So we're using base 10, right? So 5s are really important to that because it's almost the only factor of 10, right? 2 and 5. That's it. That's all you've got, right? So 5 is very, very important. It's sort of like a sub base to our base 10 system. So 5s are very, very important, right? So if we take 5s out and we look at what we got, 56. There's a 5 we can factor out, sort of. So you got the 7 is a 5 plus 2, and the 8 is a 5 plus 3. Right? So there's a 5 in both of those. Right? So really what we're kind of doing is we're looking at multiples of 5 plus 6. That's really what we're doing here. Okay. So if we do that, the first multiple of 5, 0 times 5, plus 6 is just 6, and then we get 1 times 5 plus 6, that's 11. So notice our 1's place here. We go 6, 1. Our next one, 2 5s plus 6, is 16. So our 1's place goes 6, 1, 6, and then it's going to carry on like that. 1, 6, 1, 6, 1, 6, 1, 6, right? Okay. 21 is 3 5s plus 2 3s. Now that 3 factors out, right? So now when you pull that 3 out, you get 1 5 left over plus the 2. 5 plus 2 is 7, okay? So that's why 3 times 7 is 21, or it's a way you can think of it, right? Because what we're doing is we're looking at multiples of 5, and we're adding 6 to it, okay? Now the next one, 4 5s plus 6. We can factor a 2 out of that, so you get 2 5s plus 3, so that's 2 13s. So now, this doesn't look like it on the surface, but this is related to this whole system, because now what we're doing is we're adding a multiple of 5 to the 3, but the 2 isn't getting a multiple of 5 added to it, so it's just staying at 2. Instead of appearing as like a 7 or a 12 or something, it's staying at 2. Okay, so 26 is part of this system. 31 is part of this system, but it's prime. Okay, so 5 5s plus 6. 36 Now we're getting into anti-prime territory over here. So 6 5s plus 2 3s. You can factor a 2 out to get 3 5s plus 3, so that's 2 times 18. So here we're seeing where the 8 is related to the 3, right? Because it's an odd number of 5s plus that 3. And that's where we're getting a 6, right? An odd number of 5s plus the 3 gives us a 6 over here. Odd number of 5s plus a 3 gives us a 6. Or we could factor the 3 out. Now we get 2 times 5 plus 2, that's 3 times 12. Remember how I mentioned that the 2 can show up as a 7, a 2, or a 12. Over here, if I factored this, it's either 2 times 3 or 3 times 2. That's why I didn't note it, but let's actually do that. So this would be 2. Yeah, let's do it on this line. This line is more honest. 2 times 3. And I'll just trust that you can see that that's 0 times 5 plus 3. And then over here we've got 3 times 2. Okay. So now we're going 2, 7, 12. We just keep adding a 5, right? And if we add 5 to 12, we get 17. We get over here, we get 51. Okay. So we're skipping 2, skipping 2, skipping 2, right? Here we're skipping 1, skipping 1, skipping 1. Why didn't I finish writing this out? So this is 2 times 8. Okay. So the 2's, if we're looking at 2's, we're skipping 1 each time. If we're looking at 3's, we're skipping 2 each time. Okay. So when we get to 56, we just got a 3 at 51, so that's why we're not going to get a 56, because we need to skip 2. But at 51 was odd, so 56 is even, so 2 will go. And now, half of 56 is 28. If you notice, this is 7 4s. If I take the 4 out of that and multiply it by the 2, I get 8 times 7, or 7 times 8. Right? So in a sense, there's a 7 built into this because it's a 28, but also there's a 3 built into it because it's a 28. Right. So this isn't revealing all of the ways you can factorize these things, but it is revealing a pattern that spans all of these values that end in a 6 or a 1. I don't have 1 in here. 61 is then prime. Neither of these work, and it's not always going to be the case that if neither of them works, it's prime, but it is a strong indicator. Okay, right? So for 11, neither works, it's prime. 31, neither works, it's prime. 41, neither of them works, it's prime. 61, neither of them works, it's prime. 71, neither of them works, it's prime. The next one where neither of them works is 91. Okay, so this is the one where I gave you that misdirect. I showed, I was like, okay, this one looks prime. It does look prime when we think about it this way. But, so we can't factor because 17 and 2, 5, and 3. We can't factor anything out of this, right? So neither of these work. We can't pull a 3 out, we can't pull a 2 out. But this one is just 7 times 13. Right, so this one, in a way, it's related to 56, because this is 7 times 8. It's related to 56 in a way that's kind of like a third option, a third way of looking at this, right? So 21, 7 times 3. So let's put that down the middle right here. 7 times 3 goes there. If we add a 5 to the 3, we get this. If we add a 5 to that 8, we get this. So there's a third sort of way to look at this, where we're just looking at, we're keeping the 7, and we're adding multiples of 5 to the 3 part. And that's where you get 91. So there's a lot in here. There's a lot in here that is really interesting and very, very informative, and a lot to play with to teach kids intuitions about things. Intuition specifically about things that are, one, it's intimately tied to the way base 10 works, but not in a way that we ever really show anybody. Right? Because everything here, all three of these patterns, what we're dealing with is multiples of 5 being added onto just these awkward things, 2 and 3, that we're not that comfortable with. And it's giving us 1s and 6s. All of the 1s and 6s. And we're getting these nice, beautiful patterns, right? So these 7s, they're skipping quite a few, right? So what am I skipping? 6? Makes sense, right? Because I'm doing multiples of 7, so every 6 gets skipped. With the 2s, I'm skipping 1. With the 3s, I'm skipping 2. With the 7s, I'm skipping 6. Like there's a lot of structure here that's just never show anybody. And some of this I just discovered right now as I was talking about it, because I've never been shown this. I've never thought to look for it before. So yeah, I think there's some problems with the way that we're teaching pedagogically currently. This is really, really nice. 12 equals 3 times 4. And 56 equals 7 times 8. 1, 2, 3, 4, 5, 6, 7, 8. That's a really nice little anchor point that you can give very small children just as soon as they're able to count. And then you can start talking about all of these structures that are just built in here, and you're getting multiplication and addition, and you're getting factorization, and you're getting concepts of primes. You're getting a lot of stuff just right here. It's just given to you almost for free if you bother to look at it. And certainly there's going to be things here that I'm at this point unaware of, but yeah. So here now you can develop an intuition about why 51 isn't a prime number, right? Just come through the current education system and you want 51 and 91 to be prime in your head, like, oh, those are prime, right? No. But here we get an intuition of why, right? Or more of an intuition. You can see the patterns that are going on.